Today I'm going to be showing a tutorial for my Homework 5 final project for the summer course CS2110 taught by Professor Graeme Bailey at Cornell University. And so for this homework assignment we were given the task of creating a graph or system of villages and roads connecting a world called GnomenWald, where then these traveling gnomes can travel between the villages along the created roads. So to start, I'm going to start showing some of the basic functionality, and then we're going to move into the more complex phase later on in the video. Okay, so what you start off with is you can start off with a blank map, which allows you then to start adding villages on your own, where you can specify a max capacity of that village. We're going to add like 2 quick villages right now, just to show some of the basic properties. Okay, so now you can move down to start connecting your graph. And then this asks if you want to make it two-way. If you say no, then it'll take the one you clicked on first and then make a directed edge there. Okay, so we're just going to add a little more. Let's say this one can be maybe two-way. Okay, so now we have this basic village. Anytime if you want to reshape your map, you can simply move it around by going back to the redraw map stage. As you'll see, if you try to create an intersection without going through a village, then it'll say no, this can't be done. Similarly, if you try to add a road that causes an intersection, and it'll say connection would result in roads crossing, and it says it can't be done. So then some of the deleting properties, you can delete a village first by just deleting every road going in and out of it. So there you see all of that will be deleted. This second delete option I'll show you in a little bit, which does a more complex deletion where it actually tries to preserve roads going in and out of the village. And then this last road, delete road, where you select the start village and then the end village, and it'll delete the directed edge from those villages. Okay, so now we're going to start moving into an example. As you can see here, you can click Save State, which will save your state to the current state.txt, which is here. But then you can also load these 3 at any time, as long as there are no gnomes present in your map. So now we're going to load the small state, and we're going to start showing some more things. So now going back to this delete village state here. So if I make this delete star for this village, instead of deleting all of these roads, it's going to try to preserve this road here, for example. Now we're going to have this long road. Similarly down here, it's going to preserve this one, but since roads already exist, connecting this village to this village, it's not going to draw an extra road. So now if we reload this state, we can also see that if you try to delete a village, which would then cause crossing, then it'll result in an error warning, and it'll reload the thing. So now we're just going to quickly reload this map, and now we're going to show you some of the graph algorithms that can be applied. So this exists path algorithm, you simply select the start and end, and it'll give you, using depth first search, a path that connects the villages if they can be connected. Now, for example, if you try to connect villages that can't be connected, for example, if you try to go 4 to 1, it'll say path does not exist, because as you can see, the directed edges don't allow you to get back to 1. Now, there's also the shortest path, which we'll see now chooses a much shorter path than the first path, which will be the shortest path connecting these 2 nodes. So now we're going to move into showing how you can start adding gnomes. So if you go to random gnome, this is the first type of gnome we have. When you click on the village, it'll simply start adding a gnome that will move randomly to a next village. Anytime it gets into the village, it looks at the villages it can go to and it moves to that village. And so how these gnomes work is each gnome runs in its own thread, and anytime it gets to a village, each outgoing road from a village has an intersection thread associated with it. And each intersection thread holds a queue where when gnomes get into a village and want to go onto that road, they go into that intersection queue. And then the intersection thread with a delay rate will dequeue the first gnome waiting and then shift everything up and then notify the dequeued gnome that now he's going to be on the road and then he should be traveling. And so we can see this in action. It'll dequeue this gnome and then he's saying, okay, now I'm on the road and now I'm going to travel. One little note, as you see, when gnomes get to a place where they can't go anymore, then they just sit in that village. So now for the other type of gnome, this is a directed gnome, a gnome that has a given path and is trying to accomplish this path. If we click on 1 going to 6, we can choose the 3 types of gnome. A lazy gnome will simply use either depth first or breadth first search to create a path to its end node. Then a normal gnome will look at the shortest path at the start and then follow that path. And then this special urgent gnome will actually move twice as fast as any of the other gnomes, and at each village that it reaches, it will recalculate the shortest path, where it takes into account the capacity of villages as to avoid very congested areas. So as we can see, this guy's going to move really quickly. And one thing that I can do to show it recalculating, you see that it first takes the shortest route. But if I start flooding village 5, then it suddenly becomes unfavorable for this urgent gnome to go through village 5. So if I make it go here, then it's going to see that village 5 is pretty full, and then it's going to take this upward path right here as to avoid this congestion. And although it's taking a longer route, in the end it'll be actually quicker for it to get to its destination. Okay, so now we're going to move to even a little bit bigger graphs, and I'm going to show you the interesting functionality that you can see there. Oh, actually, quickly, one thing that you can see is this topological sort just gives you the order of which you could traverse these villages. So you could go 0, 1, 2, 3, 4, 5, and that would be a possible order that would allow you to get to all the nodes. Okay, so now let's move to a tougher example. So you can always enter this medium state, load this state up, but for this example, we're just going to go straight to the large state, just to show you everything in action and how interesting it can become. So one final button that I didn't show you was this minimal spanning tree, and if you click it, you'll see that it's going to assume that all the edges are directed if they're not, and then it's going to use Prim's algorithm to highlight the roads that would create the minimal spanning tree for this graph. So now we're going to get rid of that, and we're going to start adding some gnomes. And as you can see, things get quite interesting. The gnomes populate the village, and then they just start moving around. Again, the cyan or light blue colored gnomes are the random gnomes, and they'll just move freely and randomly throughout the map. So I'm just going to add a couple. Okay, so now if you direct your attention down here, you'll see there's a nice little interface for looking up gnomes, and you can see that there's the IDs of gnomes that exist on the map exist from 1 to 57. So if we want to search a gnome, we simply type a number in that range, and then what will happen is this gnome will actually increase in size. And then we can keep track of the big gnome, and you can keep track of his location. We know that he's a random type gnome, and because he's random type, he doesn't have an urgency, and he doesn't have an average trips or average time. And so now he's going to go, and we can see him. We can see that his location is being updated, and we can watch him traverse the map. So now we're going to add a directed gnome. We're going to add an urgent guy. And then, since he was just added, we know that he's 58 in index. And if we follow this guy, we'll see that he's traveling the shortest path. And we can watch him go. We can actually highlight the path that he's going to be taking. And so now he's going to come back. And so one interesting thing that I showed you is that urgent gnomes are actually programmed to recalculate the path, but also any gnomes that have a directed state, what they're going to try to do is once they get to their end location, they're going to start heading back to their beginning location as if they were going from home to work and then back again. And so then we can see the number of trips that he's taken. He's gone down once and back once, so that he's got 2 trips. And then along with that, we keep track of an average time between that each trip takes. And so that's going to be updated each time he travels throughout the graph, and each time the number of trips increases. Okay, so that is basically the gist of how this all works. And yeah, so I hope you enjoy. I hope you have fun playing. One interesting thing to see again is how it is very sustainable and how everything works on its own. And I hope you enjoy playing around with these buttons, and I hope you enjoyed this tutorial. Thank you, and have a great day.